Welcome back to our Verilog tutorial series. In this episode, we'll explore the module structure and hierarchy in Verilog, as well as how to declare and use variables effectively. Let's dive in. Modules are the fundamental building blocks in Verilog. They allow us to encapsulate specific functionality or behavior, enabling us to create complex digital systems by connecting and instantiating modules in a hierarchical manner. To declare a module in Verilog, we use the module keyword, followed by the module name and a semicolon. Inside the module declaration, we define input and output ports using the input and output keywords, respectively. Ports are declared with a data type and a name, similar to variable declarations. Let's take a look at an example module declaration to illustrate this concept. In this example, we have a module named MyModule with 2 input ports, A and B, and 1 output port, C. The module functionality would go inside the module block. Once we have defined our modules, we can instantiate them within other modules to create a hierarchical structure that reflects the system's architecture. Here's an example of module instantiation within another module, Top Module. We instantiate MyModule and connect its input and output ports to signals or variables from the parent module. By using modules and instantiating them hierarchically, we can build complex digital systems. This modular approach helps manage design complexity, facilitates code reuse, and leads to more efficient and scalable designs. Now, let's move on to declaring and using variables in Verilog. Verilog provides various data types to represent different kinds of values in a digital system. Some commonly used data types include reg, integer, real, and time. The reg data type represents a single bit or multi-bit register that can store sequential data. It's often used for state variables or holding intermediate values. The integer data type is used to represent integer values within a specified range. It's commonly used for counting, indexing, or general arithmetic operations. The real data type represents real numbers with decimal precision. It's useful for modeling analog behaviors or performing floating point calculations. Lastly, the time data type is used for representing time delays or durations. It's often employed in Verilog for modeling and controlling the timing aspects of digital systems. When declaring variables in Verilog, we specify the data type followed by the variable name. We can also use the MSB/LSB notation to specify the size of the variable, indicating the most significant bit and least significant bit. In Verilog, we have 2 types of assignments used to assign values to variables: blocking assignments and non-blocking assignments. Blocking assignments are used to assign values to variables in a sequential manner. The assigned value takes effect immediately. On the other hand, non-blocking assignments are used in combinational logic to allow concurrent assignment of values. The assigned value takes effect at the next time step. It's important to understand that variables declared within a module are scoped to that module and can only be accessed from within the module. Variables declared outside any module are considered global and can be accessed by all modules. The lifetime of variables in Verilog spans throughout the simulation time, from the start of simulation until its completion. Additionally, each time a module is instantiated, a new instance of the module is created, and variables inside the module have separate instances for each module instantiation. Following proper variable scoping practices is crucial to avoid naming conflicts and ensure modularity in Verilog designs. Understanding variable lifetimes and the implications of blocking and non-blocking assignments is essential for designing robust and efficient digital systems. Throughout this tutorial, we have provided code examples and explanations of module structures, variable declarations, and assignments in Verilog. We encourage you to experiment with different variable types and assignments to gain a better understanding of their usage in Verilog designs. In the next episode, we will explore more advanced concepts in Verilog, including conditional statements, loops, and behavioral modeling techniques. Make sure to subscribe to our channel and hit the notification bell so you don't miss it. Thank you for joining us in this episode on Verilog module structure and variable usage. We hope you found it informative and helpful for your Verilog journey. If you have any questions or suggestions, please leave them in the comments below. Happy coding, and see you in the next episode.